Jedi V, and today we're going to be attacking the 2018 AMC8 problem 25. How many perfect cubes lie between 2 to the 8th plus 1 and 2 to the 18th plus 1 inclusive? Let's first review the definition of a perfect cube. Well, we know that a perfect cube is just a number multiplied by itself 3 times. So 1 cubed is equal to 1 times 1 times 1, which is equal to 1. 2 cubed is equal to 8. 3 cubed is equal to 27, and so on. Now, let's give an example of a number that's not a perfect cube. Let's say 25. Well, 25, there is no x that multiplied by itself 3 times would equal 25. So, now that we have reviewed the definition of a perfect cube, let's read the problem. It says, how many perfect cubes lie between the numbers 2 to the 8th plus 1 and 2 to the 18th plus 1 inclusive? Let's try to compute each of them. So, we know 2 to the 8th plus 1 is equal to 256 plus 1, which is equal to 257. It's a good idea to memorize the powers of 2, say up to 2 to the 10th, because they appear a lot in math competitions. So now we have the lower boundary. Let's find the upper boundary, 2 to the 18th plus 1. Now, this is a big number, and many people only memorize up to 2 to the 10th. And even if you were able to calculate this, it would be too big for you to find the number of cubes between 257 and that big number. So let's find a secret manipulation that will help us make this problem easier. So the problem is asking for the number of perfect cubes that lie between 257 and 2 to the 18th plus 1. This gives me an idea. Maybe we can apply the power rule of exponents. Aha! Maybe we could make it 2 to the 6th cubed plus 1, because this is also equal to 2 to the 18th by the power rule of exponents. So after we have this, then it's much easier, because this is literally equal to 64 cubed plus 1, because 2 to the 6th is equal to 64. Now we have simplified 2 to the 18th plus 1 to 64 cubed plus 1. Now let's look at the question. How many perfect cubes lie between the two boundaries? Let's draw a table. So there's x, and now there's x cubed. So let's start listing some of them. 5, 6 to 16, 343. We notice that 343 is just a bit bigger than 257, our lower boundary. So that means the number 257 would be just right in the middle of these two. So now the lower boundary is right here. Let's keep on going until we reach our upper boundary, which is 64 cubed plus 1. So we just keep on going all the way down to 64 and 64 cubed. So this is our upper boundary. It's going to be right here, just 1 above 64 cubed. Now, it's really easy to solve the problem, because now we're just looking for how many perfect cubes are in between this range. And to find that, all we need to do is find this total range, which is 1 to 64, so 64 numbers, and subtract it from this range, 1 to 6, which is 6 numbers. And that will give us this range. So that range is 58. Answer choice E. Problem conquered. Thanks for watching. May the force be with you. See you next time.